So in the following question, we need to find the resultant force when three forces are applied to point A. So we have three forces, which is this vector, which is 5 Newton, and another one that's 3 Newton, and another one that's 4 Newton. So in order to solve a question involving three vectors, we can actually find the resultant force of two vectors, and then we will use the resultant force to compare with the third vector. So let's say I start with this pair of vectors here. So if I take this and I put it over here, so copying this straight out again, this is 4 Newton, and that's 60. And if I want to copy out 3 Newton, so we know that if we extend this straight to here, this would be 30 degrees as well. So what I'm planning to do is I'm planning to draw 30 degrees here and 3 Newton. So looking at this, I know that this is 30 and this is 60, and that gives me a right angle triangle. So if I want to find the resultant vector, I know that the resultant vector will be this over here. So in order to get the resultant vector, what I need to do is I need to use the Pythagoras Theorem. Pythagoras Theorem will give me, say, if this is x squared equals to side square plus the other side square, I will get 25. Therefore, x equals to 5. So the resultant vector is 5 Newton. So I will leave this first, and then we know that this is done. And now we need to compare the resultant vector with the third vector here. So if I copy this onto here, so that will make it about, I'm trying to do an isosceles triangle here because this is 5 Newton and this is 5 Newton. So this will be another angle. So we sort of know that the resultant vector needs to be this one here. So how are we going to find the length of this one? We can only find it if we sort of know like another angle from this triangle, because this is not 90, and we can use cosine rule, but we still need to find out an angle. So let us draw more clues onto this diagram and see what we can do. So if I draw a parallel line extending out from here, I know that this is 120. And if I draw another line here, I know that this will be like 150. So let's say I want to get this angle here. So we'll just call this angle as angle theta. So to get theta, I know that I can use tangent theta equal to opposite over adjacent. So that's 4 over 3. In order to get theta, I can shift tangent 4 over 3 to get 53, to get 53.13. So this will be 53.13. So knowing this, I will know that. So knowing this, I know that this makes 30 as well. So that's 30. And this will be like another 150. So I can somehow find the value of this angle here. So this is like one whole revolution. So that's 360. Take 150 here and take 150 again and take 53.13. I get 6.87 as this tiny angle here. So once I get the angle and I have two sides, I can somehow figure out the third side. So let's say this side is y. So we will use the cosine rule. Y squared equals to 5 squared plus 5 squared. Take 2 times 5 times 5 times cos 6.87. We get from here 5 squared plus 5 squared. Take 2 times 5 times 5 times cos 6.87. We get 0.359. And in order to get y, I have to square root my answer, and therefore I get 0.599 Newton. So this here is 0.599 Newton. So after we have found this, we know that in order to find the resultant vector, we need to get the magnitude as well as the direction. So we know the magnitude already, but we also know that the direction is sort of heading this way. So in order to find the direction, let us consider using bearing. So bearing always points to the north, and therefore we sort of know that north is this way. And because we know that this is 53.13, we can get this angle by doing 180, take 90, take 53.13, which is 36.87. And we can also get this angle right here, because this is 5 and 5 Newton, so they are sort of isosceles. So we can use 180, take 6.87 divided by 2 will be 86.565, which is this angle here. And we will also know that this angle here is 360, take 120, take 36.87, take 86.565, we will get 116.565 as this angle here. And we know that a bearing will always start from the north to here, and this part will be sort of 90 degrees. So to get the direction of the resultant force, we just use 90 plus 116.565. So we will get 206.57 as the bearing, and that's the direction of the resultant force.